welcome back from an exciting lunch, right? Good to be together and share a meal together, right? I'm going to talk to you guys today about WLAN Pi Pro, and this is a new tool or kind of an evolution of the tools from the WLAN Pi project. And really, we've kind of evolved into this, building this multi-tool for WLAN Pro is the way I kind of like to think of it, right? It's this multi-purpose tool, and we'll kind of go through some of the new capabilities and new features that we can do with this latest edition. Real quickly, for anybody that's not familiar with the WLAN Pi project, this is a community-driven project. This thing actually was founded at WLPC, started back in 2016. So it's been around for quite a few years, and it's been really cool to see from the community aspect that continue to grow. It's focused on tools for wireless professionals. So that's really the main preface of the tool set that's on here, as you'll see. If you want more information on that, check out WLANPi.com. We'll be adding some more info to there after this session as well. But yeah, real quickly, what we're going to go through here today. We've got some new hardware to talk about. We've got a new platform to talk about. We've got new tools, new website, as well as new contributors. So speaking of contributors, I kind of feel bad actually coming up here and talking to you guys because I feel like I'm kind of stealing their thunder, right? They're the ones that are really doing all the work behind the scenes. And this core group of contributors continues to grow, and it's really cool to see now that we're getting into more of the hardware side and taking ownership on some of the hardware side on our side, some people that have been able to step up and just be involved in the project and contribute to the project. So yeah, like I said, I kind of feel bad coming up here because most of the time I break things and then these guys come along behind me and fix it. So these guys really are the ones that deserve all the credit for anything that you guys are using today. And if you guys are using any of these tools, definitely make sure to find them. Probably about half of these guys or so are at the conference here this week. So if you see any of these guys and you're using their tools, definitely give them a pat on the back and tell them how much you appreciate the work that they've been doing and those contributions. All right, so now let's talk about the evolution of the WLAN Pi project. So for those of you that have been following along, starting back in 2016, this is what the WLAN Pi platform, the hardware platform, looked like. It was a bit, hobbled together, but we had a working throughput testing endpoint, which is really what the project was kind of, the original feature that was, that founded this project. We did add some Wi-Fi, of course. We had to have some Wi-Fi functionality. Back then, we could only get, dual band, but 802.11n Wi-Fi 4 working on there, but it had a gigabit Ethernet port. One thing that was missing, though, it did not have a display. So in 2017, we quickly realized not having a display was a big pain point for this type of tool. So we were able to come up with taking that same platform, but now add a display to it. Colored display, had some programmable buttons on there, still rocking the Wi-Fi 4. And then we go on to 2018, and we move to this Neo 2 platform. Smaller platform, smaller package. Also added the OLED display, which was a nicer display to work with. And the big thing was, we were able to add 802.11ac to it at that point. And then 2019 still stayed on that Neo 2 platform, but evolved it a bit, right? Joel was able to put together this case design for it that allowed us to house the adapter, the cables, all that kind of stuff into a nice, easy package to travel with. Then unfortunately, unexpectedly in 2020, we planned to actually continue on with the Neo 2 platform, but they stopped producing that platform. And since we were basically just using off-the-shelf parts, kind of put a bit of a cramp in the project, right? We didn't really, we had to pivot at that point. We didn't really know. It was kind of, we had to look at some different options. So it was a decision time. So we explored kind of a few different options. The first option is this the end of the project? Do we close up shop here? It sounded pretty nice at the time. It's been, a lot of nights and weekends and things like that contributed to the project. So there was certainly an appeal to that, but, I think that myself and the contributors, these core contributors, these guys that are involved in this project, wouldn't allow it. They wanted to continue on. They were ready to face the next big task. So we looked at a bunch of different single board computers. I've got a pile of these things, collecting at my house, as I'm sure a lot of you guys do. We looked pretty seriously at something like a Rock Pi E, and it was nice, met a lot of the requirements, but the concerns were a lot to do with availability, right? Is this just going to be another thing where we pivot to this, do all the development work to get an image on there, and then it just disappears on us, right? So then we looked at full custom hardware. That certainly is appealing. It would give us the greatest amount of flexibility. However, there was a time constraint. Knowing things like WLPC, there was a demand for the previous generation hardware, so we wanted to try to get something to you guys as quickly as we could. And also there's a cost and a complexity standpoint and things like that are all part of that. So didn't end up going that route, but what we actually found in the process was a possible hybrid solution. I don't know how many of you guys are familiar with carrier boards. This was a new concept to me, but working with carrier boards was pretty interesting. So carrier boards kind of bridges that gap where it allows us to do something where we can build it much faster in the sense that it takes a lot of the complex pieces of the components, your CPU, your memory, that whole architecture, puts that into a single component, right? A compute module. So basically the brains of it is a standardized component, and then we're building the carrier board that mates with those pair together. So that allows us to lower that kind of difficulty level of developing this, but also speeds things up from a time to market standpoint. Since it's still custom, custom manufacturing of circuit boards, that there is still a significant cost and time associated with that, but at least it does lower the barrier from compared to a full custom solution. The other thing that I really liked about the compute module side of it, the Raspberry Pi Compute Module 4, is that this is meant to be an industrial type solution that's going to be around a while. They actually have guaranteed that it's going to be at least in production until 2028. So that was also another big selling point to us of if we're going to embrace this, it's going to be around a while and we're not going to have to pivot to something else in a year or two. So we laid out our requirements, right? We looked at, okay, the previous solution that we had some shortcomings, and as technology was evolving, it was becoming more apparent of the shortcomings of the Neo 2, not having things like USB 3, not having any kind of PCIe. We couldn't utilize the latest technology that we needed for Wi-Fi professionals. It also didn't have a battery, so you had to connect external power to it, things like that. So yeah, these were the requirements that we came up with. And a lot of these are just, through conversations with users that were using this is oh, it'd be awesome if it had this. So we just compiled that list of what are the users asking for. So yeah, then the next phase was, after we defined those requirements, we moved on to, okay, creating some prototypes to see can we actually create something that could potentially fill those requirements. So we went through a prototyping phase, then we went to production, and then we got into the fun of assembly. And this is what my office looked like just before WLPC. And thankfully, some hands that got in early also helped us assemble. You can see the picture on the right there. Those are the completed units for the deep dive that's going to be happening later today. And fast forward 1 year later from the time when we decided that decision point of, okay, we need to do something here, we don't want to let this project die. 1 year later, this is what we came up with. That's all you guys wanted to hear, right? We don't need to go into any details or anything. So let's get into some of the geeky pieces of it, right? So what are some of the features of the WLAN Pi Pro? Some of the features include you can use it as a packet capture device, network performance testing endpoint. It could become a portable DHCP, TFTP, SFTP server, Wi-Fi scanner sensor, portable AP. The list goes on, right? You can see there's a lot of different options there. One thing that I want to point out as well is the last point there around being an open, non-proprietary platform, I think is something that's very unique to this project that I really like in the sense that we have a lot of awesome developers even in the room here that I've had the opportunity to work with that they don't have the ability to develop custom hardware like this, and for their specific tool, it doesn't make sense for them to go out and do that. So I think it's a really cool thing that we can develop hardware like this that enables these software developers to be able to write some really cool apps for your phone, for your laptop, web-based things like that can take advantage of this tool. So let's get into some of the tech specs here, right? So what's inside? So we ended up with, if you remember on the requirements, one of the requirements were we wanted this thing to have Wi-Fi 6E. We didn't just put Wi-Fi 6E in it, we put 2 Wi-Fi 6E cards, right? What's better than 1 Wi-Fi 6E card? Also has Bluetooth, so that's one of the things that we didn't have in the previous version that was kind of a nice to have. Then we also put PoE in there, so we can both power it and charge it using PoE. It has a built-in battery. It has USB-C charging, USB Type-C charging port. That charging port also acts as a data port, just like with the Neo 2. We can connect over the OTG connection through the USB. So right now, I've got a single connection to my laptop. It's both charging, powering, as well as data connectivity to it over a single cable. Also with the Bluetooth, I could technically pull the cable out, and I can just run it off battery as well. But yeah, USB 3.0, gigabit Ethernet, 8 gigs of RAM, color OLED display, twice the size display as the Neo 2 had, and we added some extra buttons as well versus the 3-button solution on the Neo 2. You can see all the ports, layout and everything of them here. This is pretty much those same kind of views, but you can see from the side what that looks like as far as where everything's kind of located on there. So then it brings us up to, we've got the hardware we talked about. We had to also change the software then as well, right? This is a completely different platform than we were on, so this was a big shift from the Armbian-based solution that we were using before with the Neo 2. Now we're putting a Raspberry Pi Compute Module 4, and the cool thing about this is that by moving from what we had to this method, we've now separated out, okay, we have our hardware, WLAN Pi Pro, we have WLAN Pi OS as our software. So WLAN Pi OS is built on Raspberry Pi OS. So if you're familiar with Raspberry Pi OS, we've essentially built our tool set on top of Raspberry Pi OS. What that means is that if you're familiar and already using Raspberry Pi OS in your environments, you know what packages and things like that are available. All those same packages are available to you now on this platform as well, in addition to all of our custom tooling that we put on here. It's an open source platform, community supported, compatible with all your existing Raspberry Pi hardware that's already you probably already own, right? Raspberry Pi 4, Raspberry Pi 3. Basically, as long as it supports running a 64-bit operating system, you'll be able to run the WLAN Pi OS on that same hardware. So there's still the DIY component to this, right? So that leads us to the Community Edition, which is the Community Edition allows you to still do that DIY part of it, right? So I've kind of highlighted in the bullet point list there some of the differences between the WLAN Pi Pro and what its capabilities are out of the box versus if you're standing up a Raspberry Pi 4. You can kind of see what functionality you'll have and what functionality you won't have if you're running the Community Edition, as we're calling it. But yeah, so you can see there's quite a few things that you can still do with this kind of lightweight DIY platform to get started with this. So it's not like we're just moving to this platform and leaving the community side out of it. So I think they also pair nicely together where we can run things like a speed test from the WLAN Pi Pro as the client to maybe like a Raspberry Pi 4 that's used as like the server at the head end. So if we kind of continue on that path of the comparison, you can kind of see hardware-wise then as well some of the differences of what's included in the WLAN Pi Pro versus the Raspberry Pi 4. So the ones that I've crossed out there, those aren't going to be available either at all or at least out of the box on like a Raspberry Pi 4 that are already built into your WLAN Pi Pro. And of course, we've got some new tools in the process as well. And I want to highlight again some of this open, non-proprietary platform that allows developers to write their code to run on the WLAN Pi and take advantage of all the hardware that we packed into here. So some vendors have already created tools or are in the process of developing some tools that are then going to take advantage of some of those technology. We put a new dashboard, rewrote the whole front end. Josh put a huge effort into this and done some amazing work on rewriting this front end. It's built on this extensible framework using Flask. And yeah, you can see we can pull a ton of information. So this is really nice to just have sitting on your network to be able to pull a bunch of information either remotely from it or locally to it. But yeah, you could either plug this directly into the network locally with you or leave it at a customer site and be able to have access to all this information at your fingertips. We also have an admin interface that we've added to there using the Cockpit project that allows you to put a web-based admin system on there. One thing that is really slick about this is if you have a bunch of WLAN PIs, you can actually log into a single Cockpit instance and you can add all of your WLAN PIs to it so you can manage all of them from a single dashboard. You can see, yeah, the usage, network usage, all that kind of stuff from there. I also really like the embedded terminal that's in there. We're going to be using that quite a bit in the deep dive later today. The other tool that I wanted to talk about, and this tool actually has been around a bit, but we've reworked this quite a bit. And when I say we, again, it's not me at all. These guys here, Nigel and Josh, have spent a lot of time creating this, what I think is the coolest tool that we have on this thing. It's very near and dear to my heart because the geekiness of it, right? And I think just to hopefully help you guys capture this if you haven't used Profiler, I thought we'd try to do kind of a mass live demo in the room here with you guys and see what could happen. See, like I said, I like to break things, so let's see if we can maybe break something with the Profiler. So we're going to put this QR code up here, have you guys see if there's any victims or users that would like to scan the QR code, try to join the SSID that should be available. And I've got the Profiler running right now, so it's listening to these association frames. You will get an error. That is expected because you're not actually trying to connect to a real access point. That's the cool thing about Profiler is actually tricking your client into thinking it's an access point in order to get your client to send RWLAN Pi its association request frame. And why do we care about that? Well, if we get an association request frame, and let's see if we captured any while I've been sitting here talking. And if we switch over to the WLAN Pi that I'm connected to, and we go over to our Profiler tab, and we'll see if we have any profiles. And here we can see we've captured a couple of profiles here on the Profiler. And if I go to a profile report, I can now see a bunch of details about the client that attempted to connect to my WLAN Pi. So this is the client's, it's randomized MAC address. We can see that here. So don't worry if this is your MAC address. It's just your randomized MAC address here. But we can see what channel we captured it on. But the thing that I really like is this is what we're doing with Profiler is we're pulling out all the relevant information to a wireless engineer of what do we need to know what this client's capabilities are. So here we can see, and hopefully you guys can see this. Let's try and zoom in a little bit more. So once we have that report, we can download this report and we can even open the PCAP as well. But the cool thing about this report is now we have a bunch of information about this device and what its capabilities are. In this case, we've got this randomized MAC device. I don't know for sure what it is. It does generally try to categorize if it's an Android, iPhone, give me some information about it. But either way, what we're looking at is, does this device support all the amendments? Is it an AC device, an AX device? So here we can see this is an 802.11n device, an AC device. It has two spatial streams. It supports single user beamforming. It does not support multi-user beamforming. It does not support 160 megahertz channels. Its max power capability is 19 dBm. These are the channel ranges that it supports in the 5 gigahertz range, and it supports a total of 25 channels. So in the US, it's supporting all 5 gigahertz channels. Pretty cool, right? So yeah, the QR code thing is a new ad where now we can profile those devices just by scanning a QR code. So I put the big QR code up on the screen here, but on my device here, you'll actually see, and I can even see device profiled on the screen with the MAC address. So you guys don't get to see that piece of it, but at least you get to experience, what the report side of it looks like. And I'm still seeing pop-ups here of devices being profiled, so very cool. I'm capturing all your association request frames. Actually, on that note, before I forget, let me jump back there real quick, because one of the other things that I do really think is cool about this is not only do we spit out that report with all the relevant info, but maybe there's some additional info in there that you need, or you just want to validate that that is all the information there. It also it creates a PCAP based on that association request frame. So not only do you get the full report, everything all built out there, but now I have the association request frame of that client that came in. So yeah, how does that all work? As I mentioned, we attempt to join that Wi-Fi network by advertising a fake AP. How we're doing that is we're actually using a package called Scapy. Anybody familiar with Scapy? A few of you should be. If you guys took some Python at your boot camp, maybe that was mentioned. So Scapy is a pretty cool package that allows you to forge frames. You can create a beacon frame and say transmit out this interface, and that's what we're doing. We're forging a beacon frame. The thing that's really clever about it is that we're also putting in all sorts of interesting information elements and advertising that the radio in here is an AP, and it's 8 spatial streams. It's 802.11ax, all the max capabilities. And why do we care about advertising that this is some big, large enterprise AP? Is because the client will only ever respond with what the AP's max capabilities is. So if the AP, let's say, advertises it can only do 2 spatial streams, a client won't say, oh, well, I can do 3 spatial streams, right? Because that would be a mismatch in the communication between the AP and the client. So even if the client can support more, it will only advertise the max of what the AP says it can do. Same with the security amendments, right? So things like K and R, if you don't have K and R enabled on your AP and you try to do this profiling of a client, it will not advertise that it supports those kind of amendments if it doesn't see the AP says it can support those. So that's what makes this really clever into profiling these clients. Before you go and enable that functionality in your environment, you can now see, hey, do we have a critical client that's not going to support a certain feature? Some other things we can use with it, Wi-Fi scanner sensor. So there's a bunch of Wi-Fi scanner tools out there that I'm sure everybody has, hopefully at least one of these on their computer. There's probably, I know there's others out there, but these ones in particular we know do already support and work with the WLAN Pi Pro. I've tested at least the Wi-Fi Explorer Pro and the Wi-Fi scanner, and it works great. Wi-Fi Explorer Pro is also already updated to take advantage of the new Pro hardware in the sense that you can do 6 gigahertz scanning with it as well. So even though you don't have a 6 gigahertz radio in your Mac, you can connect a WLAN Pi Pro to your computer and do 6 gigahertz scanning with it. Hopefully I'm not stealing Adrian's thunder, but again, that is not my doing at all. So Adrian's in the room. Give him a pat on the back for that, because that's awesome. So why not, we did pretty good with that first demo, so let's do another demo, take things up a notch, right? So we're talking about Wi-Fi Explorer Pro. I've got Wi-Fi Explorer Pro running here. I'm actually not going to connect to this WLAN Pi. I have another WLAN Pi Pro because we've got so many of them. I just left one at my house. Kidding, we don't have a lot of them. But I do have one at my house. It's a prototype, so don't feel bad. You wouldn't want it anyways, but it was enough to do this functionality for this demo for you. So I've got one at my house. Let's see if we can make this work. I'm going to start initiating a scan using the WLAN Pi Pro sitting at my house. We're actually going to pretend with me, this is the Initech office, and at the Initech office, there's some users that are complaining about slow Wi-Fi, and it happens to be in one of the C-level offices, of course, and yeah, I'm not there, obviously I'm at the conference, so I can't be there to troubleshoot it, but thankfully I did put a sensor up in there knowing that I wanted to have that visibility, and sure enough, we go in, and I'm taking a look around. We've got 5 gigahertz there, but what do we see here that looks like a problem from our 5 gigahertz radios? Signal strength, right? How do we fix that while I'm here? And now I've confirmed that we've got some bad signal strength in that C-Level's office where I've got the sensor. So I'm going to jump over to the AP that's on, and we're going to go in and take a look at the radio on that AP. So let's go over to the radio here, and what's this? Somebody's been messing around with my transmit power and has lowered it down to all the way down to 9 dBm on our 5 gigahertz radio. Could switch it back to automatic, but we're going to stay with some static channels, and we'll try bumping it up to, let's say, 21 dBm. And let's see if we notice any difference now back at Wi-Fi Explorer Pro, and hopefully you guys can see this here. Pretty cool, right? What do we see happen with our signal strength? Not bad. We've got now, from that AP, we're now seeing negative 64 in our Initech network. So we can see there, maybe a little clearer now, of what happened with that signal strength, right? And now we've got it at an adequate level. I can talk to the user now and say, hey, try it again, see if you're having any more issues. And hopefully now we've resolved that issue, right? But I think the cool thing about this is I was able to make the change remotely through Aruba Central, but the interesting thing was, how do we know that's actually fixed the problem, right? Usually we just kind of crank the transmit power up and we have no idea of, one, I wouldn't have known what the signal level was in that office. And then two, I don't know what power level I should set it to. Should I crank it up to max? Should I go 3 dB increments until I have the signal level where I need it to be in that location? And now I can quickly do this.
Where's the Initech office?
It is located in Wisconsin. That's where, where the Initech office should be located, right? So yes, it is not on site here. So we're going all the way across the country.
How are you talking to that?
So that's doing a remote connection using Tailscale. If you've used ZeroTier, very similar to that. ZeroTier is Tailscale, creating that tunnel between me and the device on the other end. So WLAN Pi supports both ZeroTier and Tailscale, so you can easily get them onto a network where you can remotely access them. So it makes it easy to ship these out to different sites, plug them in. As long as they can reach the internet, you'll be able to reach it on the other end. All right, so what do you guys think? You guys want one of these? Yeah. So how do you get one? I've got one. So if you're signed up for the WLAN Pi Deep Dive, they will be available to all the students in the WLAN Pi Deep Dive. We will have some available in the store. Really, honestly, the main focus and the big push, I would love to have hundreds of these available, thousands if need be, but the reality is that we literally got these off the production run, the first batches off the production run, rushed to get them to WLPC to have them for the deep dive. Like I said, this is literally like a year start to finish of all of us, involved in this project, working nights and weekends, to get this thing ready for a WLPC. So we will have some available. Appreciate that. Thank you. Yeah, so we're going to have them available at the store. Not a lot of them, so it's going to be kind of first come, first serve. But yes, supply is going to be pretty limited on that. How much are they? That's minor details, right? Retail price on this is going to be $9.95. WLPC attendee price, the discounted price for WLPC attendees will be $7.50. And that's the WLAN Pi Pro. Do we want to take questions? Yeah, Joel's going to come up. I'll take some questions while Joel is coming up. There was a question over here.
Yeah, go ahead.
Yes. So the question was, is this if the 2.4 gigahertz software defined so can be made for sniffing 5 gigahertz? So we have two Wi-Fi modules that are tri-band modules. So either one can be doing 2.4 or 5. So Adrian, correct me if I'm wrong on this, but I believe Wi-Fi Explorer Pro takes advantage of both of those radios in there by scanning 2.4 and 5 gigahertz on the module 1 and then 6 gigahertz on module 2. But that's completely user configurable of we can do packet captures and all that kind of stuff using AirTool to specify both radios so we can do multi-channel captures with it, We could do 2 different 5 gigahertz channels or a 2, 4, and a 5, that kind of thing. Question over here? Profiler is not available on 6 yet. I'm not sure yet if we're going to be able to. 6 gigahertz has some extra restrictions at this point, at least, with transmission and that kind of stuff that we're not able to overcome. However, we're hopeful that we can, at least through profiling a device on 5 gigahertz, be able to get it to tell us information about its 6 gigahertz capabilities as well. We can still use Profiler to do 6 gigahertz association captures as well and parse out that information. If you had, let's say, a 6 gigahertz AP, you could capture that association request that the client would send to the AP. We can put the Profiler in that mode as well to just capture all association requests or to capture for like a specific SSID. All right, you ready?
Any other questions?
Battery life. We actually have about 2 hours of runtime on the battery, and it charges back up in about an hour. Yeah. Sure. Go back. You wanted the features, this one?
This feature list or the hardware?
And this was the tech specs. Mobile friendly. So the question was, what do I mean by mobile friendly? With the previous WLAN Pi, we couldn't connect it to an iPhone. The problem was is that the power that it required, and that was one of the benefits of putting the battery in there is now that the device has its own power source, we can connect it directly into an iPhone, either over USB or over Bluetooth. All right, well, Joel has some stuff to share on the case design side of it with Nick as well.
I just tagged along.
Yeah.
It's fine.
Nick's here for moral support. No, Nick was a big contributor to this, so he definitely has a lot of stuff to talk about. We collaborated heavily on this design, and so yeah.
What a Jerry. Thank you.
All right. Well, while Nick is getting all that squared away, sorry for the delay. My name is Joel, this is Nick, obviously, and we collaborated in designing the case. At the end of the day, for the actual design that got printed, I probably pushed the buttons that made the design, but Nick was super involved in feedback and testing designs, and he also printed about half of the cases, so it was really nice to double our efforts and everything. And working on a team is great to resolve problems and stuff like that, so super duper valuable. Now, just like Jerry talked about requirements, we had some requirements for the case. One of those is we wanted to be comfortable to hold, want to feel good in the hand because we kind of see it as a handheld tool. We also wanted it to be optimized for 3D printing. So we needed to print tons of these things as fast as possible. And there's certain design ideas, there's certain parts that are easy to print and certain things that just don't print well. If you've ever run a 3D printer, you know what I'm talking about. Every manufacturing type has a certain set of limitations that you have to operate in. 3D printing is no exception. We also wanted to optimize it to be fast to print. We wanted to get this thing printed as quickly as possible. Nick, how long ago did we start actually printing production cases?
Well, so as hinted by Jerry, like the hardware, we didn't get hold of final production hardware until
what?
January?
Early mid-January. Like I got a sample, you got a sample, if I remember correctly, and that's what we had. And that really bit us down the road because we found out there's some variance and some tolerances and things like the height of the buttons was different on a bunch of the production units. And oh man, there's all kinds of stuff like that we learned along the way. Another requirement, speaking of buttons, is we wanted buttons that didn't suck. This was one of the hardest things to do, especially when you're using 3D printing, because 3D printing is not very exact. So we also got locked in early on our button design because we had to tell our hardware supplier what kind of buttons we wanted. And we found out pretty late in the game that we chose poorly. So,
Or rather, there was wiggle room for improvement.
yes, thank you for, that's a much better phrasing. Wow, man, you should go into marketing or something. Also, we want a visible status and power LEDs. So there's a heartbeat and a power indicator. These come directly from the Raspberry Pi. And then there's also battery indicators along here. You can kind of see on Jerry's unit up here, the battery indicators are kind of glowing. From a distance, it kind of looks like it's on fire. It's really nice. And there's also an LED up here above the PoE or the Ethernet port. So if you plug PoE in, you get a nice indicator to say, oh yeah, you've got power from with PoE. So that's nice. We also had to do cooling. This thing generates some heat. It's got a Raspberry Pi 4 compute module inside. There's going to be some heat involved. Also the PoE circuitry, that generates quite a bit of heat. So we added some cooling vents and things like that to meet those requirements. Also, this is a big one, and Nick, you pushed pretty hard for this, as did Jerry. Actually, do you want to talk about it, the thing that you wanted? Oh,
The mounting.
Yeah.
Which one was it again?
It was right here.
Okay.
It's right here.
Okay, yeah. So one of the strict requirements from Jerry was that it must have a 1/4-inch thread. We later discovered that the original WLAN Pi case, the M3 bolt recesses, Jerry had managed to crank a 1/4-inch into those. So accidentally, the V1 design actually would house a 1/4-inch accessory.
Oh, wow.
Yeah, I know. Jerry, how could you? Sorry.
It could only do it one time for each unit. Each unit could only support it one time.
So the requirement for this case was it must have a 1/4-inch thread somewhere on it. And of course, we're all collaborating on this and trying to work to timelines and decisions get made, and then Joel is stuck with this question of like, well, where do we put it on the case? Because it's not smack you in the face obvious. But so you managed to get the 1/4-inch into the case.
It's there. Yep.
Maybe you talk about how you came up with that design, and then I'll mention the M3 nuts.
Oh, it's like how it's integrated into the case?
Yeah, because that was an interesting.
Oh, I hope I know what you're talking about, so I can show it. But tell you what, should we just take a look at the model to maybe talk through that, or what do you think?
Yeah.
Okay. How do I? Oh, this is your.
Oh,
computer.
yeah. This
I don't
is
know
my
what.
one.
Yeah, your Mac is different than my Mac, so. Yeah, do you want to just show where the nut is in there?
Yes.
So what we did is, these are just off-the-shelf 1/4-20 nuts, and I apologize if they're 1/4-20. I wish we could have done everything metric, but the standard is imperial for this. So basically what we did is we did a recess inside the case that the nut press fits into. And one of the requirements for this, as we were talking about requirements, was I wanted this to be indestructible. I wanted you to just basically like tear the case apart before the nut and where the nut sits fails. Additionally, as you tighten up like a tripod or a belt clip or something like that, I think Jerry's got one. Yep, so that's where the nut is, and he's got it looks like a holster accessory or something like that he's got on here. As you tighten that up, one advantage that we have is that it pulls the nut against the back of the case. You really can go as tight as you want. It really should not fail unless you stick like an impact driver on it or something like that. Then it might fail. I don't know. Please don't try. I don't want to print another one for you. I guess you could. I probably would print another one for you, actually. But and then another challenge that we ran into is how do you capture the nut in there? Now, one thing that you can do with 3D printing is you can print up to a certain height and tell the printer to pause, and it moves the print head out of the way. And then you can put the part in there, a nut, a magnet, whatever you want, and then tell the printer to start running again, and it goes back over and then fills in on top of that part, trapping it inside. The problem with this is now you start a print, you wait 2 hours, the printer starts beeping at you at 1 a.m., you have to go in, put the nut in, hit print, make sure everything's good again. We didn't want to mess with that. So what we decided to do is we decided to build this spot where it would press fit in, and then if you would prepare to enable the cap,
Yes.
There's a cap that goes on top and 2 little M2 screws that go in on each side to hold it together. I don't think it's going anywhere. I don't think you're going to be able to break it. I don't know. Like it really should be super duper strong. So,
but that enabled us to also. So the tolerance here, it's not correct that the nut should rattle inside this housing. So we were unable to guarantee that we would get the same 1/4-inch nuts. Like even in the UK, they do sell 1/4-inch threads, but. We instead of risking that one, we just printed these ones out, and then Joel was able to supply us with the 1/4-inch nuts.
American made, probably not American made, 1/4-20 nuts. So could we go back to the slides?
Yes.
I don't know how the gesture to get back to it. Okay, rad. Oh, and let's go to materials. Yeah. Perfect. Okay, so we had to decide which material to use. We basically have two options. We can go with either PLA or PETG. Some people call it PETG. There's some pros and cons to each one, but here are the highlights. PLA prints cleaner. This is PLA. It's a very special edition that I made just for me, with a broken screen, by the way. That's kind of fun. But some of the screens, unfortunately, had a couple of bad screens in the factory, and I managed to receive one of those. PLA prints really clean. It prints very sharp. The layers stack up really nice. It just looks really good. But the problem is it's kind of, I don't know, it feels kind of tough. It doesn't feel springy. It feels a bit more rough in the hand. And so we decided to go with PETG instead. Another thing I like about PETG is it stands up to heat better. You can leave this in a hot car. I mean, I wouldn't do it because of the battery it's in there. I try to not leave stuff in a car on a hot day. But if you did accidentally leave it in a pretty hot environment, it's not going to deform, it's not going to warp, whereas PLA absolutely can, and I've seen it happen multiple times. You really have to use PETG in circumstances like that. Additionally, when you're printing a part, adhesion to the bed is really important. As the part cools, it kind of tends to contract and kind of warp up and kind of do this. In fact, some of you, if you look very, very closely, you have to look super duper close, but every now and then you might see a little corner where it peeled up just a teeny tiny little bit. It's just a side effect of printing. PETG doesn't suffer from that like PLA does. Last thing that's nice about PETG is you get that nice textured surface. I think everybody enjoys that. I like that look, and so that's part of why we went with PETG. I think it's important to talk about what we used to model this up. So for the last WLAN Pi case, I used a tool called SketchUp. It was a Google project and then got spun out into Trimble or something like that. The problem with that tool is that it is what is known as a surface modeler. It's designed for making a surface of polygons. That does not work well for 3D printing. It also doesn't have any kind of parameter control. Nick, can we get the Fusion back up and open the parameters? And what I want to do is just change a parameter and just watch what the model does. So sorry to make you do all the driving here.
No, that's fine.
So everything in this model is defined in a parametric way. What parametric means is you build the model with parameters. You say, oh, okay, here's an object. I'm gonna go out from that object by 10 millimeters, right? You have done it with a parameter. And what's great about that is if you define a tolerance around a part, an empty space, something like that, it's a matter of going in and saying, oh, change that from 1 millimeter to 2 millimeters, and the part just changes. So let's change, we're gonna do the board length. So let's say that the WLAN Pi board was not 150 millimeters long, it was 300 millimeters long. So I just changed the parameter, and now Nick's MacBook is working super hard to do a whole bunch of math, and now we have a super long Pi. But things like this, while that is a goofy example, this is super, super powerful because it allows us to go in and make small incremental changes and tune the size and all kinds of different things in regards to the model. So I think we can go back to slides. Did you not have 3-finger?
Is that all right?
I think it's kind of cool. I think we should keep it. Now, while you're doing that, I think I'll introduce the other WLAN Pi.
We've just got a reveal.
Yeah, we're going to do a reveal. So, Jerry's WLAN Pi, this is pretty cool, but sometimes I think we should think bigger, right? And so what we decided to do is we decided to make one that is literally bigger. I'd like to introduce to you the WLAN Pi Pro Max. All the work that we did on the case, that's what... That's the thing that got applause. That's what worked. So, all right, good to know. Okay, should we go through... I think that's enough on kind of things that we did. Let's talk about... Should we just kind of go through the case and how it goes together?
Yeah.
You mind if I just take Fusion and do that? Okay.
My dog's on the left.
Oh, it's on the left.
Yeah.
Ooh, and they're tiny. Okay. All right, see if I can figure out all of Nick's settings and things for Fusion. Okay, so just real quick, I kind of want to show you sort of how this case goes together. So basically what we did is, this is your fancy one, Nick. This isn't the basic one, this is the fancy one. Okay, so one thing that I was going to show you is a different way that I modeled this up is last time when I made the last WLAN Pi case, I kind of built the case around a ghost. I said, okay, the WLAN Pi is this wide, it's this long, Wi-Fi adapter is this wide, this long. I didn't actually model up the WLAN Pi, the adapters, the cables, all the things that go around it. This time, I actually modeled up the board. So I said, here's the board, here's where the connector is, here's where the USB connectors are, here's where the battery goes, here's where the screen is, here's where the buttons go. And so I created this model and then built the WLAN Pi around it. Now this is very deceptive because the model that you're looking at now is from Nick. Mine is a bunch of squares. I mean, it looks worse than it looks worse than like Star Fox on a Super Nintendo. Like it's just like a bunch of squares, a bunch of cubes. That's basically it. Nick was on the plane and he decided to model the whole thing and beautiful ports.
As Ian Toll discovered as he walked up the aisle, there was this guy like handling a bare PCB on the airplane with calipers out, measuring, well, how big's this component? How tall is this one? And this is the end result of that.
So this has actually been really nice because now Nick can produce us full, beautiful renders. You know, of course, he was able to do renders of the outside of the case and, you know, some of the inside stuff, but now we have beautiful renders of everything, including the pins. Look at the pins inside the Ethernet jack, inside the 88C jack there. Isn't that nice? Oh, it's so nice. So now, oh yeah, extreme close-up, right? Can you turn on the back and the front? I don't know. Let's just turn on a couple of different things. And this is also another huge advantage of Fusion 360 is we can create components. So we have a front board, which is a component. We have a back board that's a component. We can turn those on and off. We can reference those components in other components, and it's really nice. So if you don't mind, can you hide the back board and just show the front board inside the case? Perfect. Okay, so another thing we had to think about as we're putting together the WLAN Pi is how does it go together? You have to build something with assembly in mind. And oh boy, did we learn some lessons. We learned, especially last night, watching everybody struggle through, put these things together. It's funny how building one is so easy. Building 80 is a nightmare. Like, you know, one is so simple, but that repetitive task over and over and over again, the difficult parts of the assembly really stuck out. But the way that we designed it is you have the orange front, and then the front board with the screen goes down in there, and then you have 4 standoffs on each corner that hold the front board down. So that's all nice, very, very simple, really nice. Then we bring in the backboard. The backboard has a couple of interconnects, some pin headers basically, and it just kind of sandwiches down on there. So now you can see that Nick has added that. And so then this is when we connect all the antennas to the Intel AX210s. This is when we connect the fan. There's a little fan and things back there. Yep, so you can see Nick pointing at the AX210s. And then the last step is to take our back piece and stick the back piece on it, and then 4 Phillips screws to kind of sandwich the whole thing together. What's that? CM4. Oh, and the CM4 needs to go in there too. That's kind of important. You kind of want to have the compute module in there. It kind of brains the operation. Yeah, there it is right there. And so yeah, there's the back case all on there, and that's how the whole thing goes together. Now, we are going to be making some changes, probably incremental changes as time goes. Like, there's a few things that we did that are, I don't know, looking back, I'm like, why did we do it that way? For example, the power button, this is actually really nice to have a full, like a larger version up here for this. We have a power button right here, so it's kind of a flexible thing that you kind of press on the side here, and that's what powers it on. And then you have status LEDs right there. Wish I hadn't put them so close to each other. You know, looking at that now, I'm like, oh man, it would have been really nice to maybe put a bigger button there, but we kind of had to keep things small because of that. So we might make some minor adjustments, kind of move things around a little bit in the next revision, and that's the beauty of 3D printing. We're not committed to an injection mold or anything like that. Really, really nice for prototyping stuff like this. Nick, is there anything else in the design?
I think I'll just jump in and talk about the M3 nuts super quick. So
yes.
on the sides, you can see next to this power glyph, there are holes, and there's also another couple of holes on the base of the unit as well. And inside here, we've housed M3 nuts, and the idea of that is to open up things that you can bolt onto the WLAN Pi. So for example, on this one, I've turned it into a man bag. But a man bag.
Nice work.
But also critically, a stand.
For your man bag.
For the man bag. And the idea here, we haven't done this yet, but we will publish the dimensions of the spacing between these nuts and the depth, so that should anybody else wish to like build things to clamp onto their WLAN Pi.
So where's Jake? Jake really wanted a loop. Is he somewhere here? There he is. You really wanted a loop on here? There you go. You can have a loop. I'm also thinking a desk stand would be really nice. Stuff that I would have liked to have done, but we just didn't have time. But yeah, we'll publish these numbers, how deep the screws can go, things like that, so that you can model your own stuff for it.
Did you see it's even got the bolts in here?
Wow,
But,
look at that.
But
Oh.
something bad happened. Yours should not look like this.
They look like that, come talk
Okay?
to us.
Yeah. If your WLAN Pi comes out looking like this, come talk to us.
Yep, come talk to us. So we should probably talk about printing a little bit before we wrap it up.
Yes.
So, yeah, Nick and I basically had 2 weeks to print a whole bunch of these things. I think we'll get there. So I'll talk about my setup really quick, and then Nick will talk about his. I printed all of mine with 2 Prusa Mark III S printers and 2 Prusa Mini printers. In fact, I bought one printer from Fernay, and Keith brought it up to Boise for me, and so I could increase my print capacity. So thank you, Keith. Thank you, Fernay. What I did is I printed the gray backs one at a time. So these took about 4 hours and 10 minutes, and I used mostly default settings when I sliced it. But then on the printer, I cranked the speed up to 130%. So they were moving pretty quick. The back took a lot longer than the front. The fronts I printed on the Prusa Minis, and these took about 4 hours each. And I just printed one at a time. I found that if I tried to print 2 at a time, I'd get some curling, I'd get some warping, and so I just decided to stick with one at a time. And I ran my printers from about 7 a.m., and they usually finished the last print job of the day at about 1 a.m., something like that. My wife is extremely patient. She didn't complain, she never does. Last time she printed a bunch of the cases herself while I was traveling, actually. So,
You want to talk about just it leads nicely.
oh yeah, it does. So this is the print setup. So I have a kind of temporary one and a permanent one. So the Mark III S's are on the, well, I don't know, this side, whatever side that is. The Mark III S's are on a couple of IKEA lac tables in my closet, in my office, and they just live there. And then the Prusa Minis got put on a bench in the laundry room next to the window. So that's where they all, you got to keep the printers happy, light, plants, happy printers, make nice prints. You want to talk about your setup?
Yeah, and the UK production house is inside a wardrobe, and you can see there are 2 Mark III S's here, and they were cranking out two oranges and 2 grays at a time.
How many hours per day did you
They were
run?
running, almost 24 hours a day, but it's great that WLPC is here now because they don't have to run 24 hours a day now. So
Yes.
no longer will the house be
Noisy.
at night.
Yeah. Cool. What else do we have before we wrap up here? Oh, case yield. At the end of the day, I had 73 complete cases, and I had about 6 failures. That's a half of a case. Usually it was curl. The print would lift and kind of curl up, and there were some that I was like, yeah, nope, we're not shipping that. That one's not good enough. And Nick, how did you fare on?
Yeah, not too bad. I think I delivered 60 cases in the end. One part of the case is extremely thin, and on removal of those from the print bed, I cracked quite a few. Joel actually repaired one of yours, but I rage quit mine and snapped the cases. Once I broke that bit, we were done.
I'm sure it was very, very satisfying.
Oh, it was very satisfying.
Yeah. Real fast.
10 seconds.
Oh, negative 10 seconds, actually. Biggest challenges, really quick, is time to get the design done was the biggest thing, because we didn't get production units until weeks before the conference. Printing takes so much time, and so that was a huge challenge. Keeping the case thin. I was going to remember the percentage, how much thinner this is than the previous WLAN Pi case.
We did work it out, how many percent thinner this one is.
This is the thinnest WLAN Pi we have ever made. It is. Thank you. That is the only Tim Cook impersonation I will do today. It's something like 4%, 5% thinner than the old WLAN Pi, so it's technically thinner. That was a huge challenge. There's just a lot of really close tolerances that we had to hit to keep things thin. So yeah, we did that. Also, just the consistency in printed parts is tough. Parts that I print in Idaho versus parts that Nick is printing on the other side of the world, you just get different tolerances because 3D printing is not exact. It just isn't. But I think it served us very, very well in this case, and I'm super thankful to have had it as a tool to get this done. Anything else, Nick?
No, that's it. Thanks very much.
Thank you, everybody.